Alright, welcome to Advent of Code Day 17, and today we're gonna solve Chronospatial computer problem, which is pretty interesting. I just scrolled down, clicked on get your puzzle input, and it was kind of way too small. So we'll see, maybe we can just use like a really random programming language for this one, if it's like really simple. So let's go through the problem statement. I haven't read it yet, so let's see it together. The historians push the button on their strange device, but this time you all just feel like you're falling. So which okay, probably I have no idea about this. So, but I guess I have 30 stars on this, so I probably solved it, but I don't remember it. Situation critical, the device announces. Um. Oh, initializing the debugger. Oh no, is this the? I mean, I remember the. Oh, yeah, whatever. The small handheld device suddenly unfolds into an entire computer. Okay, it seems like a 3-bit computer. Its program is a list of 3-bit numbers, 0 to 7, like 0, 1, 2, and 3. It's weird. 3-bit computers would be like from 0 to 8. 8 exclusive. The computer has also 3 registers named ABC, but these registers are limited to 3 bits and can instead hold any integer. So I guess they aren't limited to 3 bits. Okay, that's pretty cool. So only the memory is kind of limit, but it's not really a memory, it's a program, but I mean it's a memory. The computer knows 8 instructions, each defined by a 3-bit number, and that's an opcode. And each instruction, okay, so an operand, a number called instruction pointer identifies the position in the program. It starts at 0 and it moves forward. And except for jump instructions, the instruction pointer increases by 2 after each instruction. So it points at the first instruction and the instruction pointer is incremented by 2 to move past the instructions opcode and its operand. It's in, okay, so okay, it's weird. So each instruction, okay, I guess I skipped over this one. So we have basically instruction and operand, right? Combo operand 0 to 3 represent literal values 0 to 3. Combo operand 4 represents the value of register A, B, C. Combo operand 7 is reserved and will appear in part 2. That's what this thing actually means. The 8 instructions are as follows. The advance instruction. So, so 4 is a pointer to A, 5 is a pointer to B, and 6 is a pointer to C. Okay, fine. The advance instruction performs. Wait, what? Performs division? That's weird. The numerator is the value in the A register, and the denominator is found by raising 2 to the power of the instruction's combo operand. So an operand of 2 would divide A by 4 to the power of 2 is by raising 2 to the power of the instructions combo. Okay, like no. So an operand of 2 would divide A. Yeah, 2 to the power of 2. I'm stupid. So an operand of 5 would be like 2 to the power of B, because 5 was a pointer to B. Okay. So we truncate to an integer and then write to the A register the BXL instruction, opcode 1, calculate the bitwise XOR between register B and the instruction's literal operand. BST operand modulo. So modulo here is going to explain that it's whatever, and its operand. Okay, calculates the value of its combo operand modulo 8 keeping its lowest 3 bits. So it's like shift, you know what I mean, it's just shift actually. Then writes that value to the B register. Oh my god, there are so many instructions. Jump node 0. Okay, the JNZ instruction does nothing if the A register is 0. However, if A register is not 0, it jumps by setting the instruction pointer to the value of its literal operand. Okay. And it if this instruction whatever, it increases by 2. The BXC instruction calculate bitwise XOR of register B and register C. Oh, so it's B XOR literal. B S T jump node 0 B bit, or I guess B XOR C. Then we have output. Obviously we need this one, 5. It calculates the value of its combo operand modulo 8, then outputs that value. If a program outputs multiple values, they are separated by commas. The BDV instruction works exactly like the advanced instruction, except it does it to the B register. So B divide literal. And then we have CDV, which does C division, but I guess it's A divided by the literal, and we keep this thing into the B or C registers. Okay. So here they give us an example, A, B, C, and then we have 0, which was, if you remember, A division. So it divides 7 to 9 by 1, basically, 1 to the power of 2. Or was it to the power? Yeah, so it's division by 2. Okay, yeah, so it's just your first task is to determine what the program is trying to output. To do this, initialize the registers to the given values and then run the given program, collecting any output produced by out instruction. And it says always whatever the final output will be. So this will be the final output. Using the information provided by the debugger, initialize the registers to the given values, then run the program. Once it holds, what do you get if you use commas to join? Wait, what the fuck? What do you get if you use commas to join the values it output into a single string? So do we need to copy paste with commas or without commas? That's gonna be the one. Yeah, I guess with commas. Like if it's highlighted and it's not with commas, then it's dumb. But what do you get if you use commas to join the values in? it output into a single string? I guess so. I guess with commas. Yeah, so I guess it's kind of straightforward. What do we have to do? Not sure what programming language should we use. I mean, for this one, would literally be funny to just use assembly. But again, it's gonna take like 2 hours just to read the input. Like that's the reality of it, right? So the other option would just be to like what? Um, put the input directly into the assembly code, but that would feel lame. So I'm not gonna do that. So then I don't know, let's just use something like Lua, I guess. Why not? So yeah, let's see mix packages if we can find. So it's just Lua. That works. So flake mix. So if I just add packages Lua. Oh, I'm curious about another one. If we actually, I know there is an LSP for Lua, so let's vim docs, because I was using the LSP for Lua when, like before the Nix stuff, because you know the configuration for Vim is written in Lua, so that's where I was using Lua. But I think you need to I think I need to actually install it somehow. And I'm not sure if so Nix package. I'm not sure if it's a Nix package. Lua LSP. I mean it's maybe it is. Lua language server. Okay, so there is Lua language server. Okay, so we could just install it. So we do enable. Oh, I mean it's what the fuck. Then I just have to copy paste this thing into NixVim and it's just gonna work. So we just make it through. I mean honestly I'm gonna remove most of these once I'm done, but would be really cool if you were able to somehow have like a Nix, like a Vim config per project, like being able to say that in this project I want to enable go please or something like that, right? If you know what I mean, but I don't know how to do that. It's kind of, yeah. Okay, so if let's start up the thingy. Let me just download get day 17 now. Okay, So we can make day 17 directory, and let's go into day 17. So we have a Lua, nice. Let's see if we are able to actually create a main.lua file. Okay, and no, let's just see how we do IO with Lua. Lua language IO. And tutorials point, yuck. Let's see the Lua programming language. The IO library. So we can do like IO write. I mean, I know it has print because I was using printing inside of Vim itself. So I can print hello. Well, I don't think you need a function. So if I do Lua main Lua, it should run it. Okay, nice. Let's just copy one of these. Right. So the idea is erase the whole file. Curious, do you actually, can you actually, is it just this easy? It's like way too easy. Oh, fuck. I crashed it. Okay, yeah, no, holy shit, it's just that easy. Nice. So yeah, I didn't know that you can actually just read a string like that. Perfect. Perfect. So local count, if line the call to, I mean, what I'm interested in now is just to split by lines and do those sorts of things. But I mean, the input is kind of, you know what it looks like, so Lua split by new line or split by string. I know it's with like gmatch or something. Huh. Interesting. So, I mean, that's just it. This is just the function, I guess. It's weird, but it's like we have also I have to say local function. Local function split takes in an input string, a separator. So I guess percentage %s is like any white space. Then we create this t, which is in Lua we only have tables. We don't really have anything else. So you use the table as an array, right? It's like JavaScript would only have the objects. So it declares this table, and then for each for str in string gmatch. So gmatch, I think it works like let's say like how Vim does the, how do you call it, the percentage s thingy. So you can see here in their example for word in string.gmatch, and then they use percentage a plus, which is words basically. So yeah, do print word. So I'm curious what we can do here. Split the lines, although let's see if split actually works. So here we have t, then we have for string gmatch input string, and then we have like a regex expression, but it's weird because it contains the separator. Can we actually, maybe t is equal to split input and give it a new line? What sucks is that this displays like table, so lua print table. I don't remember how you dump a table properly, so we'll just, okay, inspect was a thing I was using in Vim, but I see it's like a dependency, so cannot use that. But yeah, I really like that for this language we actually find stuff, so people are not gatekeeping like in other languages. People are, yeah, I mean, I see, but this just returns a string, so we still have to use print. So okay, so it splits the lines, that's nice. And it even, interesting, it even knows how to ignore the, it even knows how to ignore the empty lines. That's perfect. Anyway, now what do we need to do is to take the first three lines, and one thing to be careful about is that indices start at 1, but that's only because there are no like arrays. Everything is a dictionary in Lua, so it's actually a dictionary with key 1, so it's not really an array. Okay, so we take the first three lines and we get the values of the registers. That's kind of straightforward. So let's create a parse input function. So local function parse input. I think it's camel case, but function, and we get in the input. And yeah, obviously I know you can somehow create comments with the types to have type hints, but come on, like, okay, so we split the input, right? Then we need to somehow split the first three lines by let's say semicolon space. So I would say maybe something like print the, let's say t1. Let's see if parse input, let's see if it actually works, right? And then I can have split t1 by semicolon space, and let's see the dump of this one. So we get as expected register, then equals. Wait, was it an equal? Ah, it's A. Wait, but why? I see. So it doesn't really split by a single character, it splits by a list of characters. Interesting. So let's say we split by semicolon, right? And then we take the first one, and do we have string lua? Like, I guess with gsub or gmatch as well, right? Like, it's the same idea. So this way we should only see 729. Wait, what? Oh, literally, I said that you need to be careful about indexes and okay. Wait, why is there a 1? The fuck? That's so random. Did you see that? The fuck? String.gsub. So gsub returns a copy of s in which all occurrences of the pattern have been replaced by the specified replacement. So yeah, like you pass the string, the pattern, and the replacement. So here it means that we want to replace %s with nothing. Oh, it's gsub, not gsub. Why the fuck is there a 1 at the end? Maybe the dump is no, but it's okay, whatever. Let's see. Lua convert string to int, let's say string to int. Okay, so we have two number. Let's see if I do two number, if it dies because of that one. So okay, so this works. I don't know why gsub didn't work. It's supposed to just remove the white spaces, but for some reason it's cooked. Whatever. So we have 729. So that's how we get, for instance, A. Or I guess A. No, let's call it capital A. Why not? All right. Then we get B by doing this, C by doing this, and we have a list of numbers now on the last line. And I think we should split again. So program, we take the fourth one. Let's actually let's name ABC. Local, why not? So we have ABC and program. Perfect. But program should actually be a table, right? And we can create an empty table. And then we have Like if we try to print this one, but let's do a dump. Okay, we should see that it's like that, the second item, which is the important part that we care about. Right. Again, it's annoying with that this G sub thingy. I mean, why wouldn't I just copy paste this one? Because it looks like it worked for this guy. So all trim, and let's see what this prints. Interesting. So this one actually worked compared to the other one. Okay, so let's say we have local numbers is equal to this, and then we can do the same thing, kind of like we did here. So for num in, and we can do basically split numbers by comma. And how do you, it's like do and end, do and jk. Let's print the number. Right, let's attempt to call a table value. Wait, what? Local nums. Did I make an upsy? I guess the thing that's, but no, like I have to just use pairs if I want the indices, but I don't want them. 57. Attempt to call a table value. Okay, pairs pivot. So here we get, like here, key value, but I only care about the key. Right, so it's 0, 1. Yeah, looks good. So I guess the logic here would be to just table insert, but let's make sure we do number the num. Right, and at the end, can we just return maybe something like AA, BB, CC. I don't remember if you have to do. Okay, so create table. Did I? Oh, it's with equal, I guess. And now the real question is, can I do something like this? I can, but does it does it know to, if I print dump, will it be 1 2 3 4 or will it be ABC program? Yeah, I have to, and I saw another one that here I need to say program. So print dump, and yeah, so we have ABC and the program. Perfect. So we can just do some stuff. Okay, so let's see what we can do about it. So we have add v, which is the A division. Let's actually start with local function part 1. And what this function is supposed to do is declare the local like program pointer or instruction pointer. So let's create IP0, the instruction pointer, then while IP. So this should get debugger information or something. Info. Maybe can I print dump info? Like, is this maybe how you index? Part 1 info. Shit. So let's say, yeah, that's it. So Lua table length. How do we get the length of a table? Okay, I guess you just create a function for that. Makes sense to me. So shit. Okay, so this is a local function. So that's how table length would work, right? You do a for loop and you increment the count. It's weird that they didn't have this one already. So while IP, I guess, when does the program stop? I guess the program halts when you get outside of the program. Local n, I guess. Right. Let me just say program is equal to info program, just to have it perfect. So that's how we do this one. Then can I say like local, and we have operators. Opcode and operand. So let's say opcode is program of IP, and I would have to say IP. I'm programming like in ninth grade when we were doing index 1 and less than or equal, which is kind of fun. Operand program IP+1. Hopefully this works. So this would be, let's just say, print opcode, print operand, IP is equal to IP+2. So imagine this would be the first instruction, 0, 1, which we scroll down, 0, 1, it means that we do division, we divide A with 2 to the power of 1. So let's implement add. So local function add. I guess we are gonna take in an info and return an info back. We could modify it in place, but I don't. We could just do it like this. So local A is gonna be info A, or you know what, like add takes in the A and operand. So it's like just doing like Lua raised to power. Come on, someone, mathpow. Someone is gonna give us the exponentiation operator. That's perfect. So A, and we divide 2 to the power of operand, and I'm just gonna use parentheses because I'm scared. So let's say that if, and you know what, I think I also want to have like local A is info A, local B is info B, local C is info C, because yeah, and here it's gonna be something like if opcode is equal to 0, Lua if statement. Let's see. So it's with then, that's what I wanted to see. So we use then, right? And honestly, I mean, we could just say like this is the add operator or opcode, and we just do it here, 2 to the power of operand. Right, so if we print A before and after, we should see Lua floor. We want to math floor, but not that shit. How do we floor? I guess it's math.floor straight up. Math floor. So yeah, we should see it being divided. Hopefully that's it's integer. It says it's truncated to an integer. Okay. All right, so that's the first operator, right? Let's do something like else. Lua crash, or like throw exception or something like that. like how do I error, right? I want to say something like error, something like error, you have to implement this instruction, right? Or something like that. Error message Lua string interpolation. I mean, yeah, fair enough, F strings. So number, wait, doesn't work. Dumbass. So opcode, and then I can say something like probably plus plus. Opcode is not implemented. Or maybe it's just plus to concatenate strings. Lua concat string. I thought it's plus. It's the, yeah, I remember it's something like the same character twice, but I didn't know which one. And nice. So operator 5 is not implemented. So let's I mean, logically I have to say opcode is equal to 1, then implement all of them, but okay, so let's do the bitwise XOR. And I think you remember that someone said that XOR is the CSGO console key. So of register B and the literal operand. So if it's a 1, we have BXL. And that's just B XOR operand. Else if BST opcode is a 2, then we have BST, which is calculates the value of its combo operand modulo 8. Then writes that value to the B register. And we already have a problem. Here it also matters what the operand's value is. So I have to say maybe if operand is less than or equal to 3, then operand is just operand, it doesn't matter. But if operand is equal to 4, then operand is equal to the value of the A register. And if operand is equal to 5, then operand, I guess this is else if operand is equal to B, else if operand is equal to 6, then operand is equal to C, and else, and fair enough, if operand my greater or equal than 3, then we don't do anything. So operand is equal to operand. Let's keep that. And I want to add operand is invalid. Right, so that's how we are gonna take care of the operand. Right, to make sure. Okay, so if it's a 2, then we modulo by 8. We modulo the literal, like the operand by 8, and we save that into B. So we do something like operand modulo 8. Hopefully that's modulo. Jump not 0. So else if operand is equal to 3, then it does nothing if the A register is 0. So if A is equal to, I guess not equal to 0, then end. Lua should use this. So if it sets the instruction pointer to the value of its literal operand. And it also doesn't jump anymore, so I guess IP is gonna be equal to operand, right? And since we are doing a +2 there, I'm inclined to say -2, but that's kind of lame. I'm gonna do that, why not? Right, so if it's not increased by 2, so we have to do -2. BXC, it's okay, so it's now we get the XOR between B and C, and we store that into, okay, so else if operand is equal to 4, then we have to do B is equal to B XOR C, right? So B is equal to B XOR C. For legacy reasons, ignores the operand. Okay. Oh, it's not operand, it's opcode. What am I doing? Opcode. That was almost a disaster. Else if opcode is equal to 5, then we do the output. So we do modulo 8 on the combo and output the value. So let's say result or R is gonna be operand modulo 8, right? And we'll have like a local out is equal to an empty string, and let's just do something like out. Actually, let's make it a table. Let's make this thing a table, and we'll see afterwards. So out dot insert, no, it's a table dot insert. Into out we insert R, or I guess straight up just insert it. Okay, so that's the out, and then we have BDV. Oh, I forgot to mention, this is jump not 0, this is B XOR C, this is out, opcode is equal to 6, then we have BDV, B division, so that's not it. B division is the result is stored in the B. The numerator is still from A. Okay, so that's, I was a bit confused. So B division is here, they ran out of ideas. I'm sure of that. That's why they added BDV and CDV. So that should be everything. And at the end of this entire thing, we should get out back. And I mean out is declared here. Okay, nice. So out is gonna be, I guess, out 1, and let's print dump out 1. Let's see if it's at least 83. Wait, someone fucking lied. Lua XOR. Huh, I mean, no, they didn't. What? Wait, Lua version 5.2. Huh. Next packages. When I say Lua, what if I put Lua 5.4 packages in my Nix flake? So what if I use this one? So packages this Lua. Let's try. So if we go day 17 and I say Lua V and I try to run. Okay, interesting. So now it's no longer complete. Okay, perfect. Main Lua. So let's see what the error was. So attempted to concatenate what? Lua 99. Oh. A nil value. Shit. Wait, how do I convert it to... I can do dump. Opcode nil is not implemented. How the fuck do we get to nil though? So if I do print IP and N, maybe that works to print them both. 0. Yeah, but it never says when the program stops. Oh shit, you know what? It's because here we need to add an extra one because of Lua. Right, so we get 4, 6, 3, 5, 6, 2, 1, 0. Okay, so it looks good to me. So what do I want to do here is Lua string join. But I'd like to have interesting table concat. Ooh. Ooh, that's exactly what I wanted, right? We want to table concat out. So this is like the answer for part 1, right? 4, 6, 3, 5, 6, 3, 5, 2, 1, 0. I mean, it is. Why wouldn't the real? It's even shorter. Okay, I mean, oops, what? Let's see. I mean, if I think about it, I think it would have been shorter if I solved it by hand, but it is what it is now. So let's print opcode, let's print operand A, B, and C. So there's a bunch of things happening. So we have 2, 4. So it does BST on its combo operand, and then it writes to here. So, shit. No, I mean what? So 4 means, yeah, 4 means this number. So it's fine. 7. Then we have a 1 operator, which is just division. So it does division of a register by, wait, what the fuck? So 1 is just division. No, 1 is BXL. So it's doing a XOR with 1. And it makes sense, it's becoming 6. Then we have C division, which takes A, divides by 2 to the power of 5, and it stores it here. So it's literally Python 3, this divided by 2 to the power of 5. So 2, 5. Wait, what? 7. So 2 to the power of, they do something stupid in the 2 to the power, no, it's 2 to the power of operand. The fuck, how is it like it's like it divided by 6? Exactly, that happened. What? How though? Because 5 is register B. Yeah, then that's fine. Then it's 4, 6. So 4, 6 is basically bitwise XOR between B and C. So it does bitwise XOR between these two numbers, between 6 and this number. So if I do this XOR 6, we should see, yeah, I mean, that looks fine. So then it's 1, it's like 0, 3, which just divides this number by 8. 3, 5, something. That looks good. Then it's 1, 4. So 1, 4 means XOR between B and A. So this number and this number, and it stores it into B. So that looks good as well. So weird. Like, what went wrong? 3, 0. Let's see what 3, 0 would do. So instruction 3 is jump. It does nothing if A is 0. So if register C, Okay, whatever, like, okay, 2 4. I think we already looked at 2 4. 2 4 calculates the value of the combo operand modulo 8 and writes it to b. So it takes this thing, it does modulo 8, returns 7, and it stores it into b, and then it's 1 1, which was XOR between, I mean, it's the same thing again. Then it's a 4 6 again. So it continues with 4 6, which was working. Okay, and it reaches here again. 7 5. 7 5. Then 4 6. What the fuck did I do wrong? I mean, I really couldn't tell. Zero 3. So 0 3 would mean just divide. And that's fine. And then 1 4. So it's bitwise XOR between 1 and 4. That works. 5 5. It does an output. Then outputs that value. The fuck? I mean, let's say this one. Like, let's take instructions at random and see which one fails. So 0, and it means here it divides by 8. Or wait, 2 to the power of 3. Integer division. So the numerator is the value in the A register here. And the denominator is found by raising 2 to the power of the instructions combo. So here 0 3, it means that it did 13. I mean, it is 1, yeah. Then it's 1 4. I swear to God, if you have to remove the commas, it's insane. Bitwise XOR between B and what's in here. Wait, okay, so with 1, so it's 5. Yeah, I mean, I literally have no idea what went wrong. The fuck? Do I just have to remove the commas? It's like, it doesn't make any sense because from the requirements it looks like you have to put commas. Yeah, no, you have to put the commas. The fuck? But it's strange how EMP works fine. It's also much shorter because it doesn't have, like, the real input has like a while loop inside of it. You can see that it divides this number by 8 multiple times, right? And that's what it prints. But I cannot figure out what happened, what went wrong. Right. So remember how I said that we are indexing based on 1? So I was just looking at this thing, and I was thinking that if we have an opcode of 3, then we need to do the +1 before we do this if statement. So maybe we have to do something like if opcode is equal to so if the opcode is 3, so imagine that we have a 4, or wait, not really. Do we have to actually do that? Like I mean, I can save it by saying go to continue, but nice, continue is here. So we just continue, but I have a feeling that this +1 should only happen if the operand is less than or equal to 3. No, it should happen every time, but I have a feeling that that's what breaks it. The +1. So let's think about it. Let's say we have a 2, which means you have to go to the 2 index, but in our case it's 3. No, I think the +1 is fine. It's annoying, but I think it's fine. But yeah, it's still the same output. I don't know, honestly. Wait, how the fuck does yeah, whatever. I was like, how does Lua know how to print this stuff like that? But anyway, yeah, I have a feeling that it's about this trash operand here in the instruction pointer. Like it doesn't jump where it's supposed to. Oh, so it's fucking stupid here. It says that here is the literal. So combo operand is only used for this division, but here it's not used. That's fucking annoying. That's annoying. Let's say combo is 0. So we have to find where we have to use the combo operand. So here, for instance, for add division. So then for the opcode, it's the literal value. BST uses the combo operand. Jesus. Jamnot 0 does nothing by setting the instruction to the value of its literal operand. So here it's operand +1 because you know why it's +1. Then here it doesn't matter. Outputs the combo modulo 8. Then instruction 6 is the same as first one, so it's also combo. Oh my god. So it's a different output now, but is it the correct one? I think this looks the same as before, so should try it. Jesus. I mean, yeah, that was something really annoying. I literally missed it. I mean, it's a wall of text, so obviously I missed it. But yeah, I mean, it, makes sense that there was a trick like this to make you waste some time, but kind of annoying one. Anyway. Yeah, sure, it made sense because you don't want to overflow in some cases, but yeah, whatever. It's fine. We still got it in the end, so it is what it is. And it looks like it didn't matter that we did a +1 here, so that's fine. Okay, let's see part 2. So we are digging deeper into the device's manual and we discover the problem. This program is supposed to output another copy of the program. Unfortunately, the value in register A seems to have been corrupted. You'll need to find a new value we put into A so that the program's output... Oh, so we are implementing a quine. What is the lowest positive initial value for register A that causes the program to output a copy of itself? Well, I would start with this as the answer because look how big it is, and we'll see if it's bigger or lower. If it's larger than this number, then we cannot do it. Okay. At least we know we have to start somewhere here, right? So let's see what we can do for part 2. So part 2, how is it gonna work? I still like this simulation. So I think I'm actually gonna return out here. Return out. Out 1. And we are printing this for part 1. So let's say part 1 is this stuff. Let's call it out. Let's see if it still works. Yeah, so part 1 gives us that, and here we return let's say the new program. All right, so I need a function lua check if two tables are equal. Let's see how to check if two tables are equal. Thank you. Oh, this is the comments I was talking about. Hopefully this, I mean, we would just have to compare the lengths and then iterate both of them, check the keys are equal and so on, but I'm just not doing that. Let's just try to... Okay. Alright, so I think that gives you like some kind of type hints, but I'm not sure. So let's try to implement part 2 now. So part 2 is gonna take in an info, right? And we need to build some kind of while loop. So while true, let's do some stuff. Let's start with new a is equal to, you guessed it, we are gonna use this one, because fuck. And we are gonna say something like info a is equal to new a, right? And then new a plus equals 1 at the end, or I guess new a is equal to new a plus 1. Perfect. So what we have to do is to call to part 1, which is gonna give us the new program. So new program is equal to this thing, and we have to check if the new program is all equals, yeah, if the new program is equal to the old program. So info program. So here I'm going to do something like if equals program new program, then break, or I guess then just return a new a. And here how did we get here? Okay, reachable code, fine. So result is equal to part 2 info, and let's just print a dump result. Let's see if it's actually somehow running. No, let's help it. Let's help it by saying 300k. Let's see if actually, let's see how fast it goes. So I'm gonna print new a. I'm curious how big the number is. Oh, so 500k, it's actually small. Let's do 3. Actually, let's do something like, so it's 3 zeros. Let's do 5 and a bunch of zeros. It's still too low. Interesting. So let's start at 5. How big is this? 3 zeros, 3 zeros, 500 million. Let's start at 500 million. I mean, it said that it's too low, right? With ignore empty. Let's ignore empty. And I'm pretty sure it's gonna be like above 60k, 60, 100 million. So I don't know what ignore empty does, but yeah, honestly, it sucks. But you know what we can also do is we can go here. Let's develop. See, we can actually start multiple threads and search. Now let's do search from 900. Lua. So this one searches from 900 million. Okay, what the fuck am I doing? Let's develop. I mean, search up. Let's do from 1 billion. Why not? Honestly, one of them is gonna work, so let's search from I guess half of this thing. Let's see, I mean, at some point we can test again here, right? So we can take, like, for instance, this number and see if it's too small, and then restart our search. So this is 1.5 billion. It's too low. It's still fucking too low. Okay, I guess it's too low. No. What if I put 2 zeros? Like, I'm curious about this number. How big is this? 11 zeros. The answer is too low. My God. I literally cannot think of a solution that involves like doing like an equation here. I cannot be bothered to think about a solution. Right, because you think about it, what do you have to do here to get but I mean, at least let's keep it running while we are thinking about it. So let's change it to for the left one. Right, so let's see, because we have some kind of instructions, right? And I mean, just brute forcing it's an idea. But I mean, I literally don't know how to solve it, so it is what it is. I cannot think of a solution here. Yeah, I mean, maybe it's time to try another number. Like, let's say I'm doing what are the chances this is too big, too small? Ah, okay, so we are cooked. It's not telling us anymore. Okay, I guess we can just not do part 2, and we can try to look into what opcodes and operands we are having somehow. So opcode, operand, ABC. Maybe we can find something useful. I mean, maybe we can find something useful if we do a +1 into the, and we try to compare these things. So let's try to do that. Oh shit. Let's see what happens if I do a +1 here. Right. So obviously it's like this is gonna be 1 greater. But then see how different this thing is. this is still decreasing, which is pretty decent, and at some point it becomes the same value, right? But these other numbers are extremely different by just modifying with 1. Oh, and then there's the same stuff. Interesting. So in the end it kind of becomes kind of the same. What the fuck? Just let me go on the... Okay, so you can see this stuff. Oh, even these numbers are equal, but the beginning is not. I mean, as I said, I think it's like it's a while loop that does some division on the first number. So it's like 2 4 1 1 7 5 4 6. I want to see where it repeats itself. So then it's here, it repeats itself, right? So it's 2 4 2 4 1 1 1 1 7 5 4 6 0 3 1 4 5 5 3 0, and then again. So these are the instructions that it repeats. Can we make a list of them? Let's try to make a list of these instructions. So instructions 1, 2 4, instruction 2, so it does a BST. Okay, so it does something like B is equal to 4, which is A modulo 8, right? That's what the first instruction does, because it's 2 4. It's 2 4, so it means it does modulo 8 on the combo operand and 8. Nice. 1 1, it means that it divides, no, it's this one. So it does a XOR between B and 1, and then so B is equal to B. Let's use the Lua notation, B1, right? At least that's what I think. Now, what would be even easier to do if I split this, X develop, then we go into day 17 and then we run Lua. So we see better. So first instruction is 2 4, which, as we said, it's BST between A and 8. Then we have B XOR literal. Then we have 7 5, which is 7 5 is C division by. So here we do 3-step is C is equal, no, yeah, C is equal to A division by 5, which is B actually, right? Then we have first instruction is a 4 6, so it's B XC, so it does XOR between B and C and stores in B. So B is equal to B XOR C. Then we have 0 3, which is A is equal to A division by, wait, I think I fucked up here. That's 7, because it's 2 to the power of B, right? And for 0 is A is equal to A divided by 2 to the power of 3. right? I think that's third one. 7 5. Yeah, 7 5. It's combo operand. Okay, as it says here, operand of 5 will divide a by 2 to the power of b. Okay, so we have this one, and then we have 1 4. Then there are so many of them. What the fuck? I thought there were less. 6. So we have 1 4 kind of again. So 1 4 is gonna be b XOR literal. So b is equal to b XOR 4. Shit. 5 5. Oh my god, 5 5. 5 5 is output. So 5 5 will output. So 7 is output. 5 5 is output. It's gonna output b modulo 8. So output b modulo 8. That's important because b is what we output then. 5 5, then it's 3 0. And 3 0 is just jump to the beginning. 3 0 is just jump. So if a does nothing if a register is 0. However, if a register is greater than 0, jump 0. So jump to first instruction basically. So I think that's the list, and I'm pretty sure in get your puzzle input we'll see 3 0 at the end, 2 4 1 1 7 5. Oh, so I could have just looked at this, but yeah. So this is the literal code that happens if we just translate it. So I guess the goal now would be to somehow try to figure out what a should be. What a should be. Oh shit. Yeah. So we should try to figure out what a should be such that we get the same output. So an important one is that we update a here, right? So we somehow need to say that, okay, a should be at least a number that when you like divide by 8, or you have to divide it 16 times, right? So we get the 16 outputs, because if we check the puzzle input, we have 16 numbers here. So if you Python treat, oh, if we split by comma and compute the length, it's going to be 16, right? So we have 16 numbers that we need to get when we do output. So it needs to be at least 16, 8 to the power of 16, I guess, the number, right? Python 3, 8 to the power of 16. So it has to be at least this number, actually. Interesting. But initially b is gonna be this. What happens if you XOR by 1? What happens if you XOR by 1? So if the number is even, it becomes just the odd version of the same number, otherwise it becomes even. So yeah, maybe we can somehow mush together these instructions. So for instance, let's keep these instructions, the original ones, and let's try to optimize it a bit. So like try to put them together. All right, so for part 2, I just decided to hard code the instructions, and basically what I did was just a for loop over the characters that we want to get from the puzzle input, so these ones, but in reverse because it's going to be easier. Then we have a list with the previous options that we can use, or I guess the numbers up until this point, and then we decide to add some number between 0 and 7 to the current number, and we are gonna try to run, like here I just hard coded the instructions because I don't know why it didn't work when we did it with the scuffed part 1, like no idea why it didn't work. So yeah, but here it's basically just getting the previous number, we multiply it by 8 and we add the last digit, right? And we do just multiply by 8 and numbers between 0. Maybe that's what I did wrong before, but I don't remember. I think I always did times 8, but I'm not sure. It's because we are working with base 8 stuff, right? So it's gonna make more sense. But I guess this is just hard coded for my, or I guess for these ones. So maybe if we can just change this thing to be the scuffed version that we did before, maybe that works. I'm not sure though. We can try that. Let's do scuffed version here, right? So I guess that's what I want to add. But yeah, all in all, this one seemed to work, but again, it's just for my own solution, right? You can see the numbers there, but if I just run it, I get something, and we can try to see if it's the right answer. It actually was this time, Jesus, and it was also pretty fast. But again, maybe we can make it somewhat generic. So let's bring back our old part 1 scuffed. So let's see. So part 1 scuffed. And so the idea of part 1 scuffed was that we don't execute opcode 3, so jumps, we don't execute jump, but let's have scuffed version. So scout version should return the B3. So when we do output, instead of this stuff, I'm just gonna say return combo modulo 8. I think that's what I want to do. So no returns, no continues. Right. So then in here for B3, I can say just part 1 scuffed, and we pass in the info, and basically we can say that info A is just equal to A, right? Or that stuff right there. All right, so I think that should hopefully work for any kind of solution, right? It just runs the scout version. So maybe this just works for anything. Yeah, no, let's just read this. Yeah, but I don't think it works for TMP. So TMP, I don't think it works. Oh shit, it actually worked. What the fuck? So why didn't it work the first try? So the first time we did something similar. I mean, we had the same kind of stuff, but it's weird why it worked now. Huh. Right? It's kind of strange. I mean, whatever. At least we got it with this one. Yeah, like we had the same for loop here. We also had previous, if I remember correctly. Maybe we had a different function for this part, if I'm correct. Yeah, we had a different function for this one. I think I did maybe I was computing the A wrong, but I have to rewatch that part to remember. But I don't know if I'm even gonna add it, because it's gonna be like 4 hours long if we do everything. But yeah, I mean, this was the idea from the beginning, just do a for loop over all the digits, starting with the last one because that's the easiest to get, and then just use part one scuffed, which doesn't do jump, and when we do opcode it just returns. When we do out it just returns. So yeah, that was the idea from the beginning. I don't know why it didn't work. I think I was doing module 10 or something. Wait, module is not even needed here at this point. Yeah, it's... fuck. I guess it just worked now. That's pretty cool. So if you input this thing as the A register, you get kind of a coin. That's kind of cool. I mean, fine. I mean, the problem was okay, I guess. A bit annoying. Like, what was the annoying part was the difference between literal and combo, because that was confusing for me, but it is what it is. Like I wasted like 10 minutes on it maybe at most, but yeah, for part 2 that this was brutal, like, honestly. And I'm not even sure what mistake I did initially, because we started with part 1 scuffed. I mean, I just rewrote it in the simplest way possible, and I tried to just hard code. Maybe I should have done that from the beginning. Try to hard code my solution, because uh, I don't know, I just saw that, okay, it's possible to use part 1 for part 2. We can try to do that, but I got kind of sidetracked by that, and ended up in a rabbit hole instead of just hard coding the solution. And then after we made sure that it works, we should have done this thing like I did now. So yeah, hopefully this was interesting. At least I'm gonna try to just keep the parts where it worked first try, so you don't have to waste time going through the entire thing. So yeah, so let's see in the next one. So see you.